Okay, so hi everyone. We are the stock price prediction team. Our team members include Kathleen, Charlie, Jeffrey, and me, Yolanda. So let's begin by first just a brief introduction about how we started this project. Um, so I think we all know the stock market is really big right now. It's always on the news and it's pretty influential to the global economy. So we were wondering like if we combine this with another really hot topic, which is machine learning and AI, what sort of thing would result? Yeah, and also when we first started this project, we were all beginners to machine learning, so we also wanted to start off with something that's beginner friendly. So we were doing a bit of research online, and then a lot of the articles suggested to try stock market prediction. Yeah, and another thing is I think for machine learning projects, as the previous groups have mentioned as well, data collection is a huge problem. I guess you can put it that way. But for the stock market, there's constant data. There's always trades, so it's easier to get the data. Um, yeah, and so we wanted to try a project just to learn about some applications of AI and machine learning in the real world. Next, just a bit more into the technical details of the goals of our project, what we wanted to accomplish. So first, we wanted to learn the basics as well, since when we started in September, we were completely new to machine learning and AI. So we wanted to spend some time going through different tutorials or courses to learn about the backbone and the basic knowledge first. And then, so that took about a few months, I think. And then after that, we started to apply the knowledge that we learned in those courses to our project, which was trying to predict the stock market price. Yeah. And of course, with any projects, we just want to have fun and learn something new. Yeah, I'll pass it on to my teammates to talk about more details.
Yeah, so like Yolanda mentioned, we were all relative beginners to machine learning. So the first sort of part of our project involved basically learning new concepts and technologies regarding the field. So for the first two, machine learning by Stanford University and neural networks and deep learning, these were courses we found on Coursera that gave us a really good insight into some of the like basic concepts that we would be using in the project. And then afterwards, when we started actually programming the project, we used the article predicting stock trend using deep learning on dzone. And this gave us a sort of foundation for starting the project. And yeah. In terms of like an overall overview of like in general what methodology and tools we used, the data sets we used were the NSE Tata Global Stock and the Apple stocks. So those are the two data sets that we used for our two models. We also used the recurrent neural network, RNN, and this was suggested to us by dzone, as well as being a little bit more beginner friendly for us. And then as with most standard projects, we use pandas, the Python library, for pre-processing our data, manipulating it so that it's in a better way for us to use. And then in terms of the Keras model that we used a long short-term memory layer, and we ran it with an atom optimizer. And then later when we do the demo, we'll go into more detail about the specifics in terms of like how our model was set up.
Yeah, so as Jeffrey and Yolanda has just introduced, our model is based on a very simple deep learning model for predicting stock prices. In addition to the model to the stock prices data that Jeffrey has just talked about, we also use a random stock path generator in Python through the seed function to generate the stock path. We then use TensorFlow to train the model and use matplotlib to plot the final result. A sample result can be shown here. As you can see, the red path is the simulated path, and the green one is the actual stock prices imported from the outside. Right now, there are still a very large discrepancy between the predicted results and the actual results. So we predict this, the reason being a bad choice of the neural network architecture. So a logical next step would be to simulate the model using a larger data set, along with implementing different hyperparameters tuning techniques to explore different neural networks architecture. In this project, we only use 4 hidden layers. So our next step would be to use Gaussian process to determine a best neural network architecture. Also, different choices of loss functions, initializers, and optimizers can also result in different prediction models, and that will also be our focus moving forward.
Yep, so next we're gonna go do our demo. Just gonna go into our collab file. So this is the collab file that we used to run the model. First, you can see, like we mentioned before, we use NumPy, pandas to do some pre-processing of our data, and then we use Keras to build our actual deep learning model. So first, we uploaded the CSV file containing all the data, and you can see we've printed them out here as well. So we first ordered them from oldest to newest, so it's chronological. And then you can also see there's the dates, the index, and the different prices. Yeah, so that's just to double check that the data are all correct. Next, we split the data into the training set and the testing set. So the first 2,000 went into training and the last few went into the test set. And then we printed out the shape to see how many are there for the train and test sizes. Next, we plotted the price change over time. So you can see the overall trend, and there's a huge bloom in 2018. Next, we scaled our data to 0 and 1. And that helps to make the neural networks converge faster. And it's overall scaling is really helpful to improve the neural net. So we did scaling here. And then we did some further processing of the training data. So we broke them down into sequences of 60. So then, yeah, and then you can see, just to double check the shape, you can see that they've been processed into sequences of 60. Yeah, so that's all for the data pre-processing. So here is our actual architecture. Like we mentioned before, we used LSTM. So you can see the different layers here. And dropout is for preventing overfitting of our data. So when we use dropout, it would, every once in a while, it would deactivate some of the neurons, and that helps to prevent overfitting to our training data. Yeah. And yeah, so like we mentioned in the slides, we use the Atom optimizer, the mean squared error loss function. And then finally, we trained for 20 epochs with a batch size of 1. And you can see it being trained here, and the loss is also decreasing as you train it more. Yeah. Okay, so now that we've trained our model, next is testing it. So in the very beginning, when we were processing our data, we split it into training and testing. So now we're just taking the testing part of our data. And so we're using the data for the next 35 days. Okay, so you can see, so in green is the actual trend, and in red is what we predicted. So overall, like the peaks and the slopes look relatively okay, I'd say. There's a slight discrepancy, but otherwise, I think for this one, the overall trend is actually pretty nicely predicted, which is really nice. So this was from our first data set. We also tried it on the Apple stock price dataset. You can see their trend here, very nice upward curve. And then this was what we showed in the slides as well. So I think in the very beginning, it was pretty good at predicting the trend, but I think as the days went on, it was more difficult to predict the upward trend. So yeah, so that's something to think about, is how do you make sure that for the later days it's also is able to predict a really good trend. Yeah. Yeah, so that's all we have for today. Thank you very much for listening, and we welcome any questions you may have.